Well, hey there, kiddos, and welcome to your very first ever Algebra 1 video. We're going to talk about writing expressions and equations. So the first thing I want you to do is I want you to be thinking about some math words that you know that we can use in verbal expressions. For example, sum means plus, quotient means divide, and is means equals, those kinds of things that will help you as we are writing our verbal expressions from our algebraic expressions, and vice versa. And so if you look at our first example, I've got x to the third power divided by 5. That's what that fraction bar means. It means divided by. And we've got to write that as a verbal expression, which means we've got to use words. Now, the words that I use may not be exactly the words that you use, but it needs to be similar. And so here is what I would say. I would say that this is the quotient of, because quotient means divide. And to represent x to the third power, that I have a variable there, I'm just going to say a number cubed, because the variable x is cubed, it's to the third power, and 5. So this tells me that I am dividing a number, x to the third power, and the number 5. That's what that all means. You also could have just been straightforward and you could have said a number to the third power divided by 5. The problem with that verbal expression is you won't see that a whole lot. It's going to be more like what we just wrote. So now if you look at number 2, there's a difference. Number 2 has an equal sign. It has 1/2 n plus 4 is equal to 10. I know it doesn't look like an equal sign on my screen, but if you look at your paper, there's definitely an equal sign there. And so when I write this, I have to show, that it is an equation by using the word is to show equals. So if I'm going to do this, I have half of a number, because that's what this represents, and so that's how I'll start this. I'll say half a number. That represents my variable. Increased, I'm going to say increased by, that shows addition, so increased by 4. So that shows addition. You could say plus 4, you could say added to 4, you could say more than 4, somehow to show that it is getting bigger. Is gives us the equals 10. And so that's how we would write that equation as a verbal expression. So let's do the next two. If you'll see that number 3, it's an equation number 1, so I've got to use the word is, and it has 2 different variables. So does number 4, and I'm going to have to use words to show that. So when I do number 3, I have 4m minus 5n is equal to -6. And so when I write this verbally, I'm going to have to show using my words that I have 2 different letters, because the fact that the variables are different, it is important, and I have to use my words to show that. And so these are multiplication, 4 times m and 5 times n, and then there's a minus sign in front of them. Okay, and so I'm going to make a verbal expression. So we're going to start with the 4m. So I'm going to have 4 times a number decreased by, since we're doing subtraction, we'll use that this time instead of increased by. And this time, to show it's a new variable, we're going to say 5 times another number, so that I can show that there are 2 different variables. So I have a number and another number, which means they're not the same, is -6. So there is my verbal expression done. So now number 4, same kind of thing. I'm going to have you pause the video for just a second and write yourself an expression, and then come back and compare it to mine. It may not match, but it needs to be close and mean the same thing. So pause and then come back and check yourself. So here's what I came up with. I have the sum of 3 times a number squared and 5 times another number. This time I used the word sum to show addition, and so I put it first to say that I'm going to do the sum of something, and then I had a number and another number to show I had 2 different variables. So let's move on and apply this to some word type problems. And so now we're going to write an algebraic expression or equation for each verbal description. So now I've got words and I'm going to write the algebra. So let's do a reminder real quick. Complementary angles equal 90 degrees. So it means you have 2 angles that when you add them up make 90 degrees, and supplementary angles when you add them up equal 180 degrees. That's important to know. So number 5 says 2 angles are complementary, which means they are going to be 90 degrees. One angle is 3 less than 5 times the other. Write an equation to find the measure of each angle. Whenever I run across a problem like this, the first thing I'm going to do is draw a picture. I know it's got to be 90 degrees, so I have a right angle. and it's split into two because to have complementary, I have to have two angles. Plus, it says that the first two words of my sentence are two angles. And it tells me that one angle is 3 less than 5 times the other. Well, that means one of them is going to be x because I don't know anything about it. It only gave me information about one angle. And that, it says, is 3 less than 5 times the other. These words, less than, when it says something is less than, that's talking about the fact that I am going to be subtracting, but it's a flip-flop word, so it flip-flops the order of what you see. So I have 5 times the other angle minus 3. That's how I represent the words less than. It flip-flops that order, and so it becomes 5x minus 3 instead of 3 minus 5x like you think. And so then it says to write an equation to find the measure of each angle. Well, if I wanted to find the measure of each angle, I would add these together, and so I would have the first angle x plus the second angle 5x minus 3, and it must equal 90 degrees. And that would be my equation. So number 6, Chris wants to buy his girlfriend a charm bracelet for her birthday. The cost of the bracelet, just the bracelet, is $85, and then it's $15.25 for each charm. We want to write an expression to find the cost of the bracelet if Chris purchases C charms. We don't know how many, we're just going to call it C. So he's going to have to buy the bracelet. That's $85 just to put the bracelet around her wrist. No charms, no nothing. But he's going to have to buy the bracelet, otherwise where are the charms going to go? Plus, it even says the word right there, plus, he's going to pay $15.25 for each charm, and he's going to buy C number of charms. We don't know how many. We're just going to call it C. We don't know how much his total is going to be, so there's no equal sign. That's the expression that we would use to figure it out. Number 7, 3 plus the quotient of 7 and a number, x. They're telling us the number is x, so they give you the variable. Subtracted from 2 times the same number. There is a bunch going on here. These parentheses tell me that this stuff and this stuff are going to be separated from each other, probably with grouping symbols, because they're going to have to go together. They may not have to have grouping symbols, but let's look and see what we have. So I'm going to have 3 plus the quotient of 7 and a number. So 3 plus quotient means divide, so I have that fraction bar, 7 and the number x. And all of that is being subtracted from something, which means that the minus sign has to go in front of it. If I am subtracting something, if it is being subtracted from, that's what's being taken away. Again, flip-flop words just like before. And it's being subtracted from 2 times the same number, which is x. If I don't put those parentheses there, you end up with 2x minus 3 plus 7 divided by x. And if you go talking about order of operations, you're going to end up multiplying and dividing before you do that minus 3 that's in the middle. And that's not what the problem says. It says that you have to do 3 plus the quotient of 7 and a number, and all of that is subtracted from. So it's got to be in parentheses. That way all of it is being subtracted from 2x. Otherwise, only the 3 is being subtracted from 2x. So number 8, a square has a side length of s. Write an equation if its perimeter is 60. Well, again, I'm going to draw a picture. I have a square. Each length of this side of this square is s. And since it's a square, I know they're all the same. So I have 2 options for my perimeter. I can do s plus s plus s plus s, or because it's a square, I can do 4 times the side length will give me the perimeter, which I know is equal to 60. So now number 9, multiple choice. Yay! So Laura wants to buy a Rock Band game that is on sale for 35% off the regular price. First thing you need to do is take that 35%, let's make it a decimal, 0.35, because I would move my decimal 2 times to the left over here, puts that decimal in front of it. So I want to be 0.35. The regular price of the game is P dollars. We don't know how much, it's P. We want the expression that represents the sale price. Well, to find the sale price, I would take the regular price, and from that I would subtract the discount, which would be 35% of the regular price. And so this would be my expression. And so if you look at the expressions that you have, A is the only one that matches. C looks similar, but C's missing the decimal, and there's a big difference between 35% and 35. So the decimal has to be present, otherwise you're not dealing with the 35%. You're dealing with a much larger number. And so make sure that you can keep the decimal in there. So the last few, so now we're going to write a problem situation from the given information. And so number 10, I know that Q is quarts of strawberries, and I have an equation, 250Q equals 10. Well, if I know Q is quarts of strawberries, and I'm multiplying it by 250, I can say that each quart of strawberries is $2.50. So here is the problem I'm going to. So I'm going to say, let's say Angie. Angie paid $10 for some strawberries. The strawberries are $2.50 a quart. How many quarts did she buy? Now, this isn't the only way to write a problem situation for that expression. You could have looked at it a different way and said that she bought 2.5 quarts instead, or however you wanted to look at it. But that's the easiest way. It's what makes the most sense to me. And so now number 11, C is the number of concert tickets. And my equation is 10 plus 35.50 C equals 258.50. So I know a total. I know that the total was $258.50. I'm again assuming we're dealing with money. And since there's a number in front of the C, it means that that amount happened for every ticket. So I'm going to assume that the tickets were $35.50 a piece. But then I have this random 10 hanging out to the side. Well, that random 10 hanging out to the side is going to be a service fee of some sort that had to be paid because you bought the tickets online, or because you had the tickets mailed to your house, or something to that effect. And so I'm going to have to write a problem that's similar, or that talks about this. So let's say George paid $258.50 for Bruno Mars tickets. The tickets, apologize for my handwriting, it's looking bad today, were $35.50 each, plus a $10 service fee. How many tickets did he buy? There is your problem situation. And so that's how we go. My pen has decided it's going to be, that's a U. How many tickets did he buy? And so that's how we go from, here's the equation and here is what the variable stands for, write me a problem situation. And we could go backwards. We could be given a problem and then write the equation. I'm sure that that's going to come up very soon. So number 12, we want an algebraic expression to represent the area of the triangle shown below. Well, the first thing that we need to know is that the area formula for a triangle is this: base times height divided by 2. Another way you've probably seen it is 1/2 times base times height. Either one works. I prefer this one so that when I have to do my base times my height, if for some reason I've got a fraction in there somewhere, I don't end up with fractions all over the place, and it's just easier to look at. So here's what I know. My height is h, so that's cool. I get to leave the h in there. And my base is h plus 1.3. So my area for this triangle is going to be the base, which is h plus 1.3, times the height, which is just h, divided by 2. Well, if I just wanted an expression and not an equation, this would be the only part you would write, and you would leave off the a equals, because once you make it a equals, now you have an equation. The problem said expression, so that's what we want. So now we have 2 questions left. Number 13, the lengths of 2 adjacent sides of a rectangle are 2x plus 3 and x minus 7, and its perimeter is 40. This word adjacent means side by side. They're touching next to each other. I'll show you what I mean. Which answer choice shows an equation that can be used to find the perimeter? Well, let's draw a rectangle. Adjacent sides of a rectangle are sides that meet at a right angle. So this side and this side are adjacent. This side and this side are parallel. Adjacent means they have to be touching. And so it tells me that the adjacent sides are 2x plus 3. So if I label this one down here, adjacent means it's got to be this one or this one because they have to be touching, is x minus 7. And if I want to find the perimeter of a rectangle, that means I got to add up all the sides. Well, if you remember rectangles, these 2 sides are the same. And then these 2 sides are the same. And so when I find perimeter, I'm going to add all those up. But if I want an expression, and I want it to be as simple as possible, I have this x minus 7 happens twice, 1, 2, plus this 2x plus 3 happens twice. There's 2 of them. And when I do that math, because it is perimeter, it has to equal 40 because it told me so up here in the words. And so my expression is that x minus 7 times 2, the 2x plus 3 times 2, and it has to equal 40. And so it looks like D becomes my answer. If you choose B, you're only adding 2 of the sides of the rectangle. Well, that's not perimeter. You've only done half of it. You have to make sure you add all 4 sides, and so that's why we multiply by 2. So B doesn't work for that very reason. So last question. A rectangle has a length of 1/4 plus 6x and a width of x plus 0.75. Write an expression that could be used to find the perimeter of the rectangle. Just like the one we did in number 13, except now it's not telling you they're adjacent. Well, length and width are always adjacent. They're always touching. The length touches the width. That's how it goes. And so to write an expression to find the perimeter, I'm going to take my length, 1/4 plus 6x, and multiply it by 2 because there's going to be 2 of them, a top and a bottom, plus my width, which is x plus 0.75 times 2 because there's going to be 2 widths just like in our rectangle above. And I don't know what the perimeter equals. I just want to be able to find it, and it said expression, so there's no equal sign. We're done. That's how we would find our expression, our perimeter for our rectangle. So that's the end of your first video. I hope you were able to get to everything. If I talk too fast, pause this, rewind it, go back and listen to whatever you need to listen to again. Write down a couple of questions that you might have over things so that you can ask questions when you come to class tomorrow. And I will see you then. Have a good rest of your evening.